Our presentation is on air sampling. I'm Michael Kuhn and my partner is Kate Tansley. Learning objectives. You should be able to list the types of air sampling methods, analyze which sampling method is best for different circumstances, and evaluate the pros and cons of each collection device. Air sampling is used to evaluate employee exposure, assist in the design or evaluation of control measures, and document compliance with government regulation. These sampling objectives define the type of air sampling selected. The four types of air sampling are personal, area, grab, and integrated sampling. Personal air sampling is the preferred method of evaluating worker exposure to airborne chemicals and is usually required for compliance sampling. The worker wears a sampling device that collects an air sample. The sampling device is placed as close as possible to the breathing zone of the worker so the data collected closely approximates the concentration inhaled. Concentration is equal to the mass of the contaminant collected divided by the volume of air passed through the collection device. The sampling device should be placed on the shoulder of the dominant hand, as this is usually closer to the source. Special steps may be required for some tasks. Area samples can be used to evaluate background concentrations, locate sources of exposure, or evaluate the effectiveness of control measures. The sampling device is strategically placed in a fixed location in the area of interest. In general, this type of sampling is not used to provide an estimate of worker exposure because conditions at the fixed location may not be the same as those experienced by the worker. Consider the use of direct reading instruments as an alternative to area sampling, as direct reading instruments can provide additional information about the variation of concentrations throughout the work shift.
Grab versus integrated sampling. Grab samples are taken to measure the airborne concentration of a substance over a short period of time and are used to identify peak concentrations. This is because brief exposures to high concentration can result in acute yet severe health effects. Grab sampling is helpful for evaluating different parts of the work cycle. For example, setups, maintenance, or spills may result in higher exposures than regular operations. This type of sampling can help pinpoint where to focus control efforts. Grab samples alone are rarely used to estimate an employee's 8-hour time-weighted average exposure. This is because they do not account for the time between samples. However, they can be used as a screening method to determine whether more extensive sampling is needed. Integrated air sampling is used to estimate a worker's 8-hour or 15-minute exposure to a particular substance. This is done by collecting one or more personal air samples for the duration of a particular task or work shift. It is called integrated sampling because the result integrates all of the various concentrations to which the worker has been exposed during the sampling period. The resulting concentration represents an average exposure over the sampling period, also known as a time-weighted average. Air sampling equipment. There are two categories of air sampling equipment: direct reading instruments and sample collection devices. Direct reading instruments provide an immediate measurement of concentration and can be used to show the variation in concentrations throughout the day. Sample collection devices draw air through media that is subsequently analyzed or weighed at a laboratory. For now, we will focus on sample collection devices. Air sampling equipment. There are two categories of air sampling equipment: direct reading instruments and sample collection devices. Direct reading instruments provide an immediate measurement of a concentration and can be used to show the variation of concentrations throughout the day. Sample collection devices draw air through media that is subsequently analyzed or weighed at a laboratory. For now, we will focus on sample collection devices. Air sample collection devices typically have a sampling train, which is made up of 5 basic components: an air inlet orifice, a collection device, an airflow meter, a flow rate control device, and a suction pump. Each of these play an important role in determining how a sample is collected. A sample collection device works by pumping air into the sampling train through the orifice. The chemical is then collected on a collection medium, such as a filter. The size, shape, and position of the air inlet orifice can greatly affect what is actually collected from the air. This is particularly true when sampling particulate exposures. The suction pump moves air through all of the components of the sampling train. The pump must be able to draw air at the required flow rate for the time required to collect the sample. The airflow rate is set using the rate control valve. Airflows are usually measured in liters per minute or cubic centimeters of air per minute. Most air sampling pumps have built-in flow rate meters to allow the user to visually gauge the approximate flow rate. However, these cannot be used to determine the actual flow rate. It is necessary to measure the flow rate through the sampling train before and after sampling to ensure that a valid sample is collected. Each contaminant sampling method has defined flow rates and minimum and maximum sample times. A flow that is too high can cause contaminants such as gases and vapors to pass through the sample media and not get collected, resulting in an invalid sample. It can also cause particulates to bounce off the media. Too low or too high a flow rate can cause a particulate sampler to collect the wrong size particles, rendering the sample invalid for comparison against exposure guidelines. Collection devices, gases and vapors. As we know, a substance is considered a gas if its natural physical state is a gas at standard temperature and pressure, that is 70 degrees Fahrenheit and 760 millimeters of mercury. A vapor is the gaseous state of a substance that is naturally a liquid or a solid at standard temperature and pressure. One method to collect a gas is through an evacuated container or a gas sampling bag. The advantage of these sampling methods is that it collects 100% of the chemical, making it perfect for complex mixtures or unknown gases and vapors. The downside is that they cannot be used for reactive gases such as sulfur dioxide, nitrogen dioxide, and hydrogen sulfide. Using the integrated method, there are two techniques that can be used: absorption with a B as in Bravo, and adsorption with a D as in Delta. With the absorption technique, the air is removed from the airstream using a pump and passed through a liquid which captures the contaminant. The contaminant must be soluble. With a gas wash bottle, air is forced through a nozzle into the absorbing solution. The most common type of gas wash bottle is the midget impinger. A fritted bubbler impinger has a higher collection efficiency because it increases the surface area of air in contact with the absorbing liquid through the formation of tiny bubbles. It is a common practice to use two impingers, one full of the absorbing solution and the other one would be empty, to prevent any solution from spilling into the pump and causing damage. In some sampling cases, such as burning wood or other materials, a substance can be a gas, a vapor, and a solid particle simultaneously, which would require collection devices for both the gas and the solid particles. Impingers are great collection devices for such cases. The adsorption technique uses tubes with granular sorbent. These sorbent tubes are often filled with, but not limited to, activated charcoal and silica gel. Activated charcoal is typically used for collecting a large range of organic vapors, including multiple vapors at once. Silica gel is often used for vapors that cannot be efficiently extracted for activated charcoal. It should be noted, however, that silica gel is electrically polar and could attract interfering polar molecules, like water vapor. With all sorbent tubes, there is a risk of breakthrough, in which the material collected passes through the collection device and into the backup section. Any collected gas or vapor in the backup section that is equal to 10% of the mass in the front section is considered significant. Note that these tubes are not interchangeable, as some sorbents can be manufactured to collect very specific substances. It is important to check with the laboratory to ensure that it will be collected in a manner that produces valid results. Diffusion sampling devices are excellent for personal sampling because they don't require pumps, making them very easy to wear. They are also inexpensive. Once the cover of the diffusion sampler is taken off, the sampling has begun. The downside to this collection device is that they are plus or minus 25% for 95% of samples tested between 0.5 and 2.0 times the exposure limit. Temperature extremes and lack of air movement can reduce the accuracy. Caloric passive monitors can also be used, changing color to a specific contaminant using a guide provided by the manufacturer. Remember that all of these sampling methods are subject to interference from other chemicals in the air, temperature extremes, and other factors determined by the manufacturer. So that is the end of the presentation. Let's recap over the learning objectives. After this presentation, you should be able to list the types of air sampling methods, analyze which sampling method is best for different circumstances, and evaluate the pros and cons of each collection device. Any questions?